Hi guys, thanks for being here. I'm gonna present a BGP root cause analysis tool, which is called Rcat. Okay. So this tool is based on a method we presented last year at NanoC 40, and well, just as promised, it's publicly available at this place. So what does it do? Well, it analyzes BGP announcements sent by routers connected to a trust collector, such as reviews, for instance, and it tries to determine which ES are the more likely to have originating, the interdomain structure changes which have led to the emission and spread of the updates which were collected by the trust collector. Well, mainly it aims at helping NOCs, providing them with an increased reactivity during outages or after plane maintenance, and also providing them with increased proactivity, pointing out where networks behaviors such as small recurrent events. Okay, so first, very few principles. Well, for every router connected to the trust collector, well, you just know at every moment it has paths they use to reach every prefix. And when you observe the behavior of this path, well, it appears that every router R has a preferred path over time to reach any prefix P. This is what we're going to call the primary path of R to P. When I mean a preferred path, I mean this is the most used path when you watch the dynamics, and it's used over hours, days, and weeks. What is more, it also appears that, well, most of the time, a given source router, which is a router connected to the trust collector, well, it uses most of the time the same primary path to reach all the prefixes originated by a given ES. So here, for instance, I've represented the routers connected to root views at length, and have just drawn all the primary paths they use to reach the prefixes originated by AGNet. This is a double-circled AES at the top, ES 20,858. Okay, what you can notice too is that, well, the set of all the primary paths, well, it's just like, let's say, a tree, okay? When you watch it, the graph, the form, well, it's just like a tree. So this is what we're going to call the origin ES tree related to ES 20,858. Okay, so now, well, what if this very link fails? Well, assuming that there's only one link between these two ES. Well, after some time, the routers connected to the trust collector, well, they should either announce a backup path to reach the destination, or at least they should withdraw their primary path. But anyway, in both cases, what you're going to observe is that all the primary paths which were used to reach the destination, well, they're just no longer available. Or said in another way, the origin ES tree is just fading. Okay, the branches which are the primary paths are becoming unavailable. So now, well, you can see Rcat just like a very big state machine which keeps track for every path of its state, available or unavailable, and it computes periodically its primary paths, and it keeps, and then listening to updates, it detects the unavailabilities of primary paths and correlates them just in order to find out what were the events, the underlying events which have led to the to the spread of BGP updates collected. Okay, so now I'm going to try to do a short live demo. Okay. Okay, so here it is. What you can see is that there is a panel with options you can set in order to filter events you're looking for. So first let's enter the checking code. And let's say we're interested in seeing events since, let's say, well, I don't know, yesterday, for instance. Okay, so what does Rcat says? It says, okay, I have found 4,925 events, distinct events, but in total I have seen 14,289 event occurrences. What does it mean? It means that in fact some of these events have occurred more than once. I'm going to detail this. Okay, so this is just the result page. So for each event, it has found Rcat display a summary. Let's say yes, it's a summary. So you have a small picture of the event, which shows all the primary paths which have been impacted by the event. You also have basic information. So here, this event has impacted only one prefix, and Rcat says that the originators of this event, so it has localized the origin of the event between these two ES. Okay. Then on the right you have a list of dates, and these dates, well, these are the dates at which the event has occurred. Okay, so you can see there are different kind of events, and okay, so big ones, smaller, and okay, for instance here, you see that this very event, well, it has occurred 215 times since yesterday, and here are all the dates at which it has occurred since yesterday. Then when you click on the date, Rcat is going to display all the details about the event, including path exploration for all the impacted prefixes. I'm going to show in detail, but first let's play with some options. So for instance, let's say we are just interested in seeing big events, so events which have impacted more than 10 origin ES trees. Okay, so here they are. Just to show you some examples. And now a very interesting point, in my point of view at least, the logical query, because here you have a lot of events, and maybe you're just interested in some of them. So the logical query provides you with a way to filter events. So for instance, let's say I'm just interested in seeing events caused by, let's say, UNet, or maybe events caused by, just try to find the pipe. Okay, here it is. Events caused by, I don't know, global crossing, for instance, or maybe you want to see events which have impacted the prefixes originated by Sprint, or maybe you're interested in seeing all the events which have impacted, I don't know, let's say this very prefix. Okay. Okay. So let me detail a little bit what I've written here. In fact, the logical query, it's made of elementary queries. Okay, so there are lots of different elementary queries you can use in Rcat. For instance, this one, well, it enables you to, when you write ORI followed by an NIS number, then it allows you to search for the events which have been caused by this ES. Okay, when you write tree followed by an AS number, then it's gonna display all the events which have impacted the prefixes originated by this event, by this AS. Sorry, and here when you write p equal and followed by a prefix, well, it's gonna search for all the events which have impacted this very prefix. Okay, there are lots of, well, there are other elementary queries to search for events which have impacted less or more specific prefixes. And what is interesting is that, in fact, all these elementary queries, well, you can combine them using logical and logical or and parentheses. So here, I've just combined all my elementary queries with using or. Okay, this is logical or. And so what I'm searching here are all the events which satisfy this global query. So let's see if there are some events corresponding. Yes, there seems to be. Okay. And well, now let's see in detail one of them. So for instance, this one. Okay, so here what you have is first a picture of the event. So as I've just said previously, it shows all the primary paths which have become unavailable because of the event. So at the top you have the AS which are double circle. It means that they are origin ES of some prefix which have been impacted by the event. At the bottom here you have IP addresses. Again, you have IP addresses. These are the IP addresses of the routers connected to the trash collector. And finally, what Rcat shows is that, well, the more likely all those path unavailabilities have been caused by an event occurring between these two ES. Okay, so you have basic information. Here are all the origin ES whose prefixes were impacted by the event, and below you have the detail for every origin ES of the prefix. You have the details for every prefix it originates and which have been impacted. You have the detail of all the paths which have become unavailable. Okay. So for instance, here you see this ES. Well, it originates this prefix. These are the routers connected to the trash collector, and these are the primary paths they were using so far. So for instance, this first router, well, it belongs to this ES, and it was using this primary path to reach this prefix, which is originated by this ES. Okay. So what does Rcat says here? It says that at this date, this router has known that its primary path was no longer available. And you can see that closing time, the other routers have just said the same thing to the trash collector. So now if you click on the prefix, Rcat displays the path exploration the different routers have undergone during the event. So here is our router. Okay, this was the primary path it was using so far, and at this date, well, it just withdrawn its primary path, and you see that about 7 minutes later, well, it announced a new path, and finally, a few seconds after, no, later, please, yeah. So just a few seconds later, it re-announced its primary path to the trash collector, meaning in fact that the event has just reconverged. The event is over, and well, you can see that Okay, using Rcat, you can see the unreachability periods caused by the event. Okay, so now back to the presentation. Okay, so just keep this part because I've done it on live. And now I'm gonna present you two case studies. First one is about the generic cable breaks. So I'm sure you've all heard about it. Maybe some of them have spent a night trying to fix that mess. And well, anyway, it was very well documented by Renesys on their blog. Especially provided this curve, which shows the number of Egyptian networks which have become unreachable during the day of the cable breaks. Okay, so here is a challenge. We're going to try to redraw this curve using only Rcat results, and we're going to try to explain what the different peaks in this curve correspond to. So first thing we need is, in fact, to build a logical query to extract all the Egyptian events caused by the cable break, and then we'll draw the unreachability curve for each of these events, and we'll sum them to see whether we're able to redraw the curve. So using Renesys and other data sources, you have here the Egyptian providers, which were the more impacted by the cable breaks, and here you have their upstream providers. Whereas more, well, a cable break, well, it can be seen as a multiple link failures, in fact, between the ES, which peer through the transmission link, which is supported by the cable. And what is more, under Rcat formalism, well, focusing on Egypt, well, we should see many origin ES rooted in Egypt. Well, we should see these origin ES trees fading. So more precisely, the events we're going to search are events either caused by the Egyptian providers themselves or caused by the upstream providers, but which have impacted the prefixes originating by the Egyptian providers. So for instance, for Nile Online, we're going to build the following logical query. Logical query. So we're searching events caused by Nile Online itself, or we're searching events which have impacted the prefixes it originates and which have been caused by at least one of its upstream provider. So this is a logical query just for Nile 9. And now we do the same for all the Egyptian providers, and using logical OR, we just build this huge logical query, which we expect will give us all the Egyptian events caused by the cable breaks. So just setting this query in our cat here, and we set the search period to the same period as Renesys curve, and we only want big events, those which have impacted many paths. So doing so and asking Rcat, the tool answers that he has found 6 events satisfying the logical query. Okay, so here they are. You see, first event seemed to have been caused by something on the link between Open Transit and AGNet. Second one was inferred to have occurred at Seabone, like the third one. And what you can notice is that the date at which they have occurred, this is a date at which, in fact, Rcat raised an alarm for the event. Well, these dates, well, they are near the different peaks in the curve. So here are the 3 other events. So this one was inferred to have been caused by flag, this one by this ES, and here the event was inferred to have been caused by something on the link between Seaborn and T-data. Okay, so now for each ES, I'm going to use Rcat details about which prefixes were impacted, and using the path exploration, just like I've shown you previously, well, I can draw the total unreachability curve related to this event, and what is more, I can detail what's happening. So at 4:30 in the morning, well, the different prefixes originated by this AS, well, they've just become unreachable. Some were lucky, like those originated by Internet Egypt, because they just found a path back. And later that day, they undergone 2 other small unreachability periods. Okay, so I can do this for every 6 events. So this is the second one. Third event. Fourth. Fifth. And the last one. And now, well, just summing all these curves, I'm going to have the total unreachability on Egyptian prefixes caused by all the Egyptian events. So here's what we obtain. And well, comparing this curve with Renesys one, here's what we get. So it seems that's a match. So what does it mean? It means that we indeed succeeded in rebuilding Renesys curve using only Rcat results. And what is more, in fact, we have shown that this global curve was made of 6 smaller ones related to 6 different events, and we have explained what the different peaks were corresponding to. So now let's in detail one of these events. So for instance, the last one. So here is the picture of the event. So you see Rcat has inferred that the event had been caused by something between T-data and Seaborn. And here you have some origin AS. I've just pointed some of them. Then here you have the detail for some primary paths joining prefixes originated by 909. And so you see that all these paths have become unavailable at about 12:23. And finally, when you watch the path exploration related to this prefix, this one, well, is what you get. So you see that, well, every router connected to the trust collector, well, they have all undergone at least one unreachability period, which have most of the time lasted from 12:23 to 13:54. Okay, so this is well the this corresponds to the unreachability curve we had previously. Okay, so now second case study, which for me highlights maybe the most interesting feature of Rcat. Well, as you can see at first sight, well, it seems to be a very small event. You can notice there is only one prefix impacted. Only 4 routers among the 16 have lost their primary paths. Even the path exploration is very limited. You see that the event reconverged very fastly. It lasts only for a few seconds, and there's quite no unreachability because of this event. So in fact, here's a question: why should we care about such an event? At first sight, there's no reason. Well, in fact, there is a serious reason to care about it. It's because it has occurred 10,757 times in the month. So it means that on average it has occurred every 4 minutes. So every 4 minutes the routers have lost their primary pass, they have triggered a decision process, selected new pass, announced them, and then only a few seconds after they got their primary pass back, so they retrigger the decision process and so on and so on. So in fact, as you can see, such an event put a pretty useless stress on the router, and well, it should just not exist. And the very problem is that this is not at all an isolated case. This curve, it shows the distribution of event occurrences during February, and what it's showing is that, well, you have only 20% of the total number of occurrences of events which were caused by events occurring only once, which could be expected to be the normal case, in fact. On the contrary, you have 50% of the total number of event occurrences which were caused by events occurring more than 30 times in the month. And last but not least, here you see that 20% of the total number of event occurrences in the month, well, they had been caused by events which have occurred more than 700 times in the month. So what does it mean? Well, it means that, in fact, a large part of the interdomain dynamics and a large part of the updates exchanged in the interdomain, well, they are related to, in fact, few events which just occur again and again and again and again. So, so fixing these events which occur so many times, well, it would just reduce tremendously the rate of BGP updates in the interdomain, and it could help reduce the stress on routers. Well, what I can just say is that maybe you wonder why these events occur and why they are not fixing. Well, personally, I think that, as I have shown previously, well, the event has not caused unreachability. Doesn't seem to have this event. The previous one. Well, it didn't cause unreachability, so we can think that performances were not depreciated, and as a consequence, no customer will never complain for such an event because it doesn't depreciate performances. And because no customers complain about it, well, no network operators are going to search for them. So such events are just invisible, but you see that they hurt a lot interdomain dynamics. So, well, thanks to Rcat, well, such events are now pointed out. And so network operators can now investigate to find out why they occur. Is it because of some intradomain oscillation? I just don't know. Maybe some medieval or a tricky IGP configuration. But the point is that today with Rcat, you are able to see such events, and then you're able to investigate and find out why they occur and fix them. And therefore, well, maybe we're going to succeed in pacifying the interdomain. I thank you. You have any question?
I have a question. My name is Ray Jiangshen. I'm from Princeton University. So path exploration after failure seems to be a problem because it really delays BGP convergence. Since you are seeing a lot of the dynamics that's going on. Have you thought about ways to improve, to reduce path exploration?
Well, that's a good question. Well, Rcat doesn't aim at reducing path exploration. I think that mainly it aims at pointing out strange behaviors or, well, helping NOCs during a big outage to provide them with feedback on what's going on and fixing problems maybe faster. But well, I'm working on other mechanism to reduce path exploration. But maybe you're talking about some works which wanted to use root cause analysis to reduce path exploration, identifying, for instance, paths which were no longer valid.
Sure, that would be one way to do it, and I've heard about some other ways as well. I just wonder if you have thought about it, since you are actually seeing the real world dynamics. Did you say you are working on something like that?
Sorry?
Did you say you are actually working on some path exploration?
Yeah, on reducing path exploration, but it's not going to be done using root cause analysis.
Oh, that's fine. We'll talk afterwards then.
Okay. Thanks a lot.
Thank you very much.